Exercise 16. Baking soda, which is also known as sodium bicarbonate. You don't have to know that. But this sodium bicarbonate, NaHCO3, this is your carbonate. The Bi refers to right here. It's a little bit of an older name, so it might be called something else now. But sodium bicarbonate, also called baking soda, is often used as an antacid, meaning it neutralizes acid. It neutralizes excess hydrochloric acid secreted by the stomach. And so most any antacid you use is going to have some sort of carbonate in it, with the classic exception of milk of magnesia. I'm getting ahead of myself. I'm sorry. I'm just going to stick to the question. Baking soda will neutralize excess hydrochloric acid secreted by the stomach according to this equation here. Milk of magnesia, which is an aqueous suspension of magnesium hydroxide, which again, you don't have to know what these species are, that they tell you right here, is also used as an antacid. Notice that in both of these equations, HCl, hydrochloric acid, is the acid we're trying to neutralize here. Fair enough? Which of baking soda or milk of magnesia is the more effective antacid per gram? Baking soda, milk of magnesia. Let's see what we got. Now, per gram. Well, how many grams of stuff do we have? We know that that coefficient is 1, that coefficient of 1. So remember, we can read that as 1 mole of this substance, 1 mole of this substance. Well, but Johnson, we're supposed to be talking about per gram, not per mole. True. But if you know the number of moles, you can multiply by the molar mass and figure out what your mass is per gram. Look at that. So let's calculate the molar masses here. Since we're starting with 1 mole, it's just going to be the actual molar mass itself. So molar mass in NaHCO3, and we're going to need the molar mass of MgOH, 2 of those. Now, I've already calculated this. I would like you, please, right now, to pause the video, calculate the molar masses for both of these substances just to make sure that you can do it and we're not trying to run before we can walk. So please press pause now. Alright, so we should have 84.01 grams per mole and 58.32 grams per mole. So this stuff, 84.01 grams per mole, and this stuff, 58.32 grams per mole. Notice what we're saying here, and this is what would be assessed on this type of problem. We're not doing a whole bunch of huge conversion factors, but we're interpreting this stoichiometric statement. In order to neutralize 1 mole of HCl, I would need 84 grams of baking soda. In order to neutralize 2 moles of HCl, I only need 58.32 grams. So, which one is more effective per gram? I can use less grams of this, of milk of magnesia, quite a bit less actually, and neutralize twice as much HCl, right? So we can associate it per 1 mole. Let's divide this by 2. Let's divide this by the 2 so we can know per 1 mole. It actually ends up being, what does that end up being? 29.2. Sorry, trying to do math in my head. Grams to neutralize 1 mole. Great handwriting. And so the milk of magnesia is clearly the more effective antacid per gram. So let's write it. Which is the more effective antacid per gram? But here's the thing, justify your answer. Milk of magnesia is more effective since only 29.2 grams of MgOH2 is required to neutralize 1 mole of HCl, while 84.01 grams of NaHCO3 is required.